Okay, so did you hear about these pretty wild science stories making the rounds?
You mean the AI-assisted baby and the dire wolves?
Exactly. A baby born with AI help down in Mexico, and then, yeah, dire wolves potentially back after, what, 10,000 years?
Yeah, it definitely sounds like something straight out of, well, science fiction, doesn't it?
It really does.
Seem totally different. They both really highlight how fast science is moving, especially with AI involved.
Absolutely. And that's what we want to dig into today in this deep dive. Take that source material and pull out the key stuff.
Yeah, figure out what actually happened and what it might mean without getting bogged down in like super technical details.
Perfect. So let's start with that first one, the AI-assisted birth. I saw the term AI baby floating around.
Yeah, the source was pretty clear. That's a bit misleading, quite clickbaity, really.
Right.
It was an AI-assisted birth. Happened at the Hope IVF clinic down in Mexico. That distinction's important.
Okay, good clarification. So before we get into the AI part, maybe just a quick refresher on IVF for anyone not familiar.
Sure. So in vitro fertilization, IVF, it's basically where they fertilize an egg with sperm outside the body in a lab.
Right, in vitro.
Exactly. Then they take the resulting embryo or embryos and transfer it back into the woman's uterus, hoping it implants and leads to pregnancy.
And this isn't brand new tech, right?
Oh, no. The first successful IVF baby, Louise Brown, was born way back in 1978. Now it's pretty common globally. The source mentioned maybe 2 to 3 million IVF babies born each year worldwide.
Wow, 2 to 3 million.
Yeah, and it also noted it's becoming more accepted and used in places like India, too.
That's incredible reach. But traditional IVF isn't always successful, is it? The source mentioned some challenges.
That's the key issue, yeah. The average success rate, according to the source, is only around 35%, which, can be tough for couples going through it.
35%. Yeah, that leaves a lot of room for improvement.
Exactly. And part of the challenge lies in things like picking the best, most viable sperm from millions, and then the actual injection of that sperm into the egg. It requires incredible skill.
But there's still a chance for human error, I suppose.
Well, yeah, even with highly skilled embryologists, it's a delicate process. So the push is always there. How can we make this better? Increase those odds. And that's where AI comes in.
Okay, so let's get into the specifics of this case. The company involved was Conceivable Life Sciences.
That's the one the source highlighted, yes.
Yeah.
Conceivable Life Sciences. And the patient was a 40-year-old woman who'd already had, unfortunately, several failed IVF cycles.
Okay, so a difficult case to begin with. How exactly did AI help?
Well, in a couple of really crucial ways. First, the AI system analyzed just a huge number of sperm, way more than a person could realistically assess.
To find the best candidate.
Precisely. It used algorithms to identify the sperm with the highest probability of leading to successful fertilization. And then this is the really futuristic part. AI actually guided robotic arms to perform the injection.
Wow, robotic arms doing the injection.
Yeah, injecting the selected sperm into the eggs with, incredible precision.
That's amazing. And did it make the process faster? The source mentioned something about efficiency.
It did. Apparently, the whole fusion process, the injection using the robots, took only 9 minutes, which is pretty quick.
9 minutes. And the results? How many eggs were fertilized?
They started with 5 eggs, and using this AI-assisted method, 4 out of the 5 were successfully fertilized.
4 out of 5.
Yeah.
That's a great fertilization rate.
A very good rate, yeah. And then ultimately, one of those embryos was transferred.
And it worked.
It worked. Led to the successful birth of a healthy baby boy, just within the last month or so, according to the source.
That's fantastic news for that family. And the success rate in this specific instance,
Yeah.
significantly higher than the average.
Yeah, the source emphasized that. With the AI and robotics combined, the success rate in this case was over 50%.
Over 50% compared to the average 35%. That's a big jump.
It really is. It suggests this tech could have, really significant potential to improve IVF outcomes more broadly if it can be replicated.
Definitely offers hope.
Yeah.
Did the source talk about, where this could go next, future applications?
It touched on a couple of things. The potential for AI to play a role in genetic editing down the line.
Genetic editing.
Yeah,
Okay,
yeah.
that opens up a whole other conversation.
It does, and even though this sounds much further off, the idea of potentially developing full-term pregnancies entirely within a lab environment someday.
Whoa, okay, that is futuristic. But the core message for now seems to be about improving current IVF.
Exactly. Offering more hope and potentially better results for people struggling with infertility, which is a huge thing.
Absolutely. Okay, well, let's shift gears completely then. From The beginnings of life to bringing back the extinct. Dire wolves.
Yeah, talk about a headline grabber. Dire wolves extinct for 10,000 years.
That number 10,000 years, it's hard to even wrap your head around, isn't it?
It really is. I mean, the source put it in perspective. Modern humans, our recorded history, civilization, maybe 5,000 years or so, we're in 2025 now. These creatures were gone long before that. They were apex predators back in the Pleistocene.
Top of the food chain. And now, this company, Colossal Biosciences, they've actually done it. The source says 3 wolves.
That's what the source reports, yes. Colossal Biosciences managed to produce 3 dire wolf pups.
How? I mean, how on earth do you bring back something that's been gone for millennia?
Well, it involves a lot of complex genetics, and again, AI played a big role here according to the source.
AI again? How so?
They did this massive comparative analysis, looking at the DNA of modern gray wolves and comparing it bit by bit to ancient dire wolf DNA, and AI was crucial for handling and making sense of all that complex genetic data.
Okay, but where did they get dire wolf DNA from?
From fossils, really old ones. The source mentioned DNA extracted from a 72,000-year-old dire wolf skull.
72,000, wow.
And also a 13,000-year-old tooth, so incredibly ancient genetic material.
Okay, so they had the ancient DNA blueprint, and they compared it to modern gray wolves using AI. Then what?
Then came the gene editing. They identified key differences, the source mentioned, about 14 specific genes related to dire wolf characteristics. Things like their larger size, different bone structure, maybe fur type.
And they edited these genes in gray wolves.
Essentially, yes. They used gene editing tools to modify the gray wolf embryo's DNA to more closely resemble the dire wolf pattern in those specific areas.
And then implanted these edited embryos.
Exactly. Into surrogate mothers, in this case, domestic dogs carried the pregnancies.
Domestic dogs as surrogates for dire wolves.
Okay. And the timeline, when were these pups born?
The source stated the first 2 arrived in early October 2024, and apparently they kept it pretty quiet at first.
Under wraps, huh?
Seems so. Then a third one, a female this time, was born sometime in 2025. So yeah, 3 pups now exist according to the report.
And they even have names, Romulus and Remus.
And Khaleesi, yeah, classic naming. And they're being kept in like a huge 2,000 acres secret enclosure somewhere. A secret dire wolf park. But the source also mentioned some pushback, right? Some skepticism.
Definitely. That's a really important part of the story. The argument from some critics is, are these really dire wolves? Or are they just heavily modified gray wolves designed to look like dire wolves?
What's the difference, really?
Well, the source used an analogy. Think about humans and chimpanzees. We share a huge amount of DNA, but those relatively small genetic differences lead to very different animals.
Ah, okay. So even if they edited 14 genes, there might be many other subtle differences that make them not quite the original species.
Exactly. Are they behaviorally the same? Do they have the same instincts, the same, dire wolfness? Or are they just gray wolves wearing a dire wolf costume, genetically speaking? It's a valid question.
The philosophical one almost.
Yeah.
Are they expected to get as big as the originals, though?
Colossal Biosciences seems to think so. The source mentioned they expect them to reach that 6-foot-tall size the ancient ones had.
6 feet tall. That's a big wolf.
Definitely an imposing animal. Whether they fully match up in all respects, well, that remains to be seen as they grow.
This whole thing, the de-extinction idea, it just opens up so many questions, doesn't it? About, well, playing God almost.
Yeah.
Or our role in the natural world.
It really does. It forces us to think about the power we now have with genetic technology. What should we do with it? What are the ethics? What are the potential unforeseen consequences of bringing back extinct species, even if it's possible?
Yeah, lots to unpack there. So just to wrap up our deep dive today, 2 pretty mind-bending stories.
Sure. We had the AI-assisted birth in Mexico, showing real potential, it seems, to boost IVF success rates and offer hope.
Right, using AI for sperm selection and robotic precision.
And then the resurrection or maybe creation of dire wolves using advanced gene editing and AI analysis. Still controversial, but undeniably a massive scientific undertaking.
And the common thread seems to be AI, accelerating things in both healthcare and this kind of biotechnology frontier.
Absolutely. AI is clearly becoming a major catalyst for progress, or at least change, across so many scientific fields. It's speeding up analysis, enabling new techniques.
It really feels like we're on the cusp of something big. So maybe a final thought for everyone listening.
Go for it.
What other impossible things might become possible in our lifetimes thanks to these technologies? And maybe more importantly, How will these breakthroughs change how we see ourselves, how we see life, and our place in the universe?
Definitely something to ponder. It's a fascinating and maybe slightly unnerving time to be alive.